your own buddies now.
So you just like mix, like this is the problem with Coriolis. It's just mix and match, right? It's like a fucking buffet of bullshit, dude. You're like scooping everything onto your plate. It's really simple. If you're on the surface of the Earth, you're supposed to be in a rotating reference frame. At what point do you leave this rotating reference frame and enter the non-rotating reference frame? At what point? Now you said, well, if you drop something vertically, then you do it or if you travel north-south, then you do it. But if you just try to stand still, no, you're not doing it. You're still in the rotating reference frame. There's no basis for any of this. There's literally zero basis for this is when we're in the rotating reference frame, and this is when we're not. This is when we have Velcro atmosphere, and this is when we don't. It's silly, dude. It's silly that you don't see how shit this is as like a scientific concept.
There's no way you could falsify it.
But Coriolis
at all. I mean, because the only way that you can falsify it is entering into the non-rotating reference frame. Stay there and see if when you get back to the rotating reference frame, is that rotating reference frame actually rotating? But you saying no, even when you go into the non-rotating reference frame, you are still rotating with the rotating reference frame. So even when you come back and you land in the same place, you just rotate it with the reference frame. So therefore, it's just basically it's not falsifiable. But then you can pick and choose you could pick and choose and say, oh, well, when you travel in the air, it's because the Earth is rotating underneath you. You can make claims about it and say, oh, that's due to Coriolis. But when you actually try to test to see if it's true and see if it's actually rotating, there's no way you can actually falsify it. There is no alternative. There's no hypothesis for it at all.
In two instances, he brought up examples where the observer is required to accelerate over a reference frame below him that's in acceleration to prove that the reference frame below him is in acceleration. I've heard this claimed by people that Earth-based Coriolis requires two accelerative reference frames accelerating in different directions from each other in order to establish that one of them is in an accelerated reference frame. It's messed up. You only need one inertial and one non-inertial at a minimum to observe a Coriolis effect.
Why are you adding more? He try to complicate it. He try to pull a fast one on Indio. Which is kind of funny because you're throwing your buddies under the bus. I don't think Matthews would say something like that. Mathew, would you say something like that?
I'm having trouble following what you're talking about. So if it's that complicated, then I don't know.
We're trying to wade through the incoherency of the Coriolis effect.
What do you mean incoherency? Do you mean incoherence?
The application is incoherent, right? So, like, when does a projectile or an object leave the rotating reference frame versus when is the air part of the rotating reference frame? Right? Because they say in one situation, such as a drone or helicopter, you're in the air, and the air is part of the rotating reference frame, so there is no Coriolis observation. But then in another situation, like this guy was saying, if you're traveling north-south or you drop something vertically, somehow magically you become in the non-rotating reference frame. We're trying to delineate, like, how do we figure out when that's supposed to happen or not? Like, what's the trigger?
It should just be defined by the non-rotating and the rotating reference frames.
Yeah, I want to measure the loss of momentum as I leave the rotating reference frame. How do I do that?
Well, first of all, I don't think the numbers are big enough that you would notice it very easily, so I don't know how you do it.
Oh. Yeah, Yeah, that's convenient.
Right. I mean, because we're talking about an alleged RPM of 0.0000694 RPM. So
yeah, but we put that in terms of velocity, right? So we can measure the acceleration change in the same units.
Oh, sure.
Mathew,
Okay.
if you take a drone to hover, is it that drone rotating with the Earth?
If the drone is flying in the air, then probably so, because like we were saying, the air generally follows.
My question
the
is only this.
ground.
Sorry, Matthew. Sorry, I don't want to interrupt you. But only this: if you take a drone, whatever. But now I'm saying you, and you put to hover, is it that drone rotating together with the air?
Yes.
Okay. Can you tell me how it would look like if Earth is not rotating? How that drone will behave?
Then it wouldn't be rotating.
It wouldn't be rotating with the Earth.
No, I'm asking you. The drone is not moving; it's in the air, but it's rotating with the air. Is that correct?
No, the drone is basically doing the same thing the air is. So the question is about the air.
Earth. I'm asking about Earth. If drone is in the air rotating, does the drone rotate together with the Earth?
No, the drone rotates together with the air.
And the air is rotating with the...
That means the Earth is rotating different from the air.
If there's wind, then yes. If there's not, then no. It's about the same.
Then no. That means it looks that it's stationary, but also drone is not moving, it's hovering, but everything is rotating. Is that correct?
No.
No. I want to understand, Matthew. I want to understand. I take a drone. I put my drone to hover in the air. Does that drone rotate together with the Earth?
No, the drone is in the air, so it's just a question about the air versus the Earth. That's the only question. You're confusing things by putting a drone up there.
My question is, does that drone, you said, no, it's not rotating together with the Earth, only with the air. That means the Earth is differently rotating from the air.
It's about
the Earth. Matthew. He's saying that the air rotating differently from the Earth. That's what he's asking.
No, unless there's wind, then it can go a little bit different. So it's
let's not speak about wind. I want to only to put drone in the air and to realize, is it this drone rotating together with the Earth or not?
The drone is doing whatever the air is doing. If there's no wind, then the air...
I'm not speaking about air.
Yes, you are. Drones fly in the air. That's the only question is, what is the air doing? The drone is confusing things.
Jesus Christ, Matthew, I want to realize if it's Earth rotating.
Yes, the Earth is rotating, the air is rotating, and the drone...
Well, do the math and figure it out and come back and tell us how big it's supposed to look to you standing there.
Well, why don't you do the math since you want to say you know everything?
Yeah. That's not my argument.
Being so hostile. Let's ask a more specific question to this person, right? So, you believe that curvature is there and curvature exists. Why are we able to see further than the curvature should allow? The curvature should obstruct vision of certain objects, but we've got many examples of it not doing that. We're able to see much further. So
because you need to look further. Not the distance.
No, the distance has been calculated. We have seen much further.
Okay, but the change in height is like very hard to.
No, they've done this at like ground level. You know, they put the camera like in like
from what level?
Water level. You know,
from what level? Ground level.
Yeah, they put the camera like in the water basically, and gotten these same observations that I'm talking about.
So no one's been able to develop any type of lens and light mixture, anything, to be able to shine a light beyond what is claimed to be the limit to the curvature of the Earth.
So to answer the lighthouse question, I'm getting just a bunch of different answers, but like it averages out to like most of the time they can reach like 16 miles or 30 kilometers, and the range of the light can be from 10,000 to 1,000,000 lumens.
Now that you're focused on lighthouses, we probably won't get too far.
It was relevant because me and the other guy were talking about, why are you so hostile? Chill.
Exactly. Like Navy ships have been known to see lighthouses
so 200,000 lumen light can reach 1,000.
Yeah. I'll give you an example of this. Lighthouses have been known to be seen by Navy ships 200 miles away.
Yeah, because they're up to like 1,000,000 lumens. So,
do we have a photograph of that? We should be able to have a photograph of that.
I wasn't the one who made the claim, so don't look at me.
Why would the Navy take a picture of a light?
That's also a really good question.
Well, it's not a good question because they're out there, they have cameras, and people take pictures all the time.
Why are they taking pictures? Why is there somebody up there taking pictures? Who's developing those in 1950?
Somebody wouldn't stand on the boat and say, "Hi, Mom," and take a picture and have that light in the background. No one's ever done that.
Why would they do that?
Well, then, if it's so easy to find, why can't you find it? Apparently, it's everywhere.
I'm just asking a question. If somebody, no one's ever done that. There's a picture. No one's ever taken a picture. So all we have to do.
No, people are taking pictures. It's just the likelihood of them taking a picture of someone being on the Navy taking a picture of the lighthouse when they're supposed to be like doing their job. Because I believe the rule of thumb is if you're close enough to see the lighthouse, you're close enough to like.
Who's going to stand there and time out Who's going to stand there and time out the lighthouse so you can say, "Ready, take the picture," and so that light is just shining directly into the camera.
Yeah.
And then while you're saying "Hi, Mom," who's doing all that? Who's doing all those calculations? Is it the navigator, the captain? Who's doing that?
Okay, let me ask this question: only Navy ships can see that far? Does that make sense to you? You have no argument there.
I don't know. The Navy reported it, not me.
Right. So,
right, what?
Any type
on
of
a clear night from sea level, a lighthouse can be seen from 10 to 20 miles away.
Were you saying 200,
that.
right?
I did. On a clear night at sea level, I can see an island 35, 40 miles away. Without lighthouses, I can see the lights on the shore at night. Don't need a lighthouse.
So let's do a. We have Google, right? Let's find a picture of someone on a boat that took a picture, and there's an island 30 miles away from.
Wait, I have a perfect one. I went to Coney Island the other day. Not the other day, but at some point. And I could see one of the islands in like Jersey or some shit.
All right. I'll open up Google Earth. I'll see how far that is.
Oh, there. Okay. Where is the measure thing? There it is. Right there to like right. There is a. Oh my God. Fucking. Oh, because I'm on the wrong one. It's 6 miles that I saw. So, and I could barely fucking see it.
All right. So
that really doesn't really answer any questions. And I thought it'd be further.
How big is it supposed to look at 6 miles away?
What do you mean, how big is it supposed to look? I'm just telling you that I saw it from 6 miles away.
Yeah, it's going to look small.
Flat Earth. Welcome to Flat Earth, then.
No.
What do you mean, welcome to Flat Earth? What the fuck does that even mean? Yeah, that's not Flat Earth. I just saw something 6 miles away. I could have.
You think you're going to see North Carolina from Florida?
No, I was asking him on the Flat Earth model with an optic powerful enough and on a clear day. The clear skies all the way through. But no one fucking answered that question. It just derailed.
No, I've answered every time you said it. We will not be able to see it because there's atmosphere. There's atmosphere that causes a large amount of refraction. You're never going to see it.
You can't change the premise of my.
No, it doesn't even that it causes so much refraction, quote unquote. You can't see through air that far.
That's correct.
Just feels like a cop-out answer, but I'll take it.
It's not a cop-out answer. Like you can look up the weather report each day. Dude, you can look up the weather report each day. The average visibility is like 10 to 20 miles, right? On a really clear day, it's like 30 miles. In the absolute most. Guys,
look, the idea is that we have.
Your mic's working.
My mic working? Yeah.
It's working.
No, well, it wasn't.
Yeah, look, the maximum distance you can technically see in the absolute clearest conditions is 200 miles, right? But that's never the case, right? That's just kind of like technically. Okay, usually it's like 10 miles, 20 miles, 30 miles, just depends on the weather conditions. Right, sometimes it's a little bit further. It just depends, right? Maximum is 200 miles.
So like in
right? But usually the angular size of what you're looking at is going to be What's that?
So like any way you want, inches, millimeters, feet, whatever the fuck. After 10 miles, how much of a drop should you see?
66 feet over 10 miles, but it depends on the observer height as well.
I'm sorry, did you say 66 feet?
Yeah, according to the globe math. Yeah.
Something that's 66 feet tall will be gone after 10 miles.
1 foot off the ground. Yep, at 1 foot high. Yep.
Yep. Or you would have to be 66 feet high to have a 10-mile horizon. Same thing. But yeah, like it drops away from you 66 feet over 10 miles.
On a ball.
We have observations where we can look across like a 20-mile lake, right? And there's no horizon, there's no curvature. We can see the shoreline on the other side of the lake. Zero obstruction.
Oh shit. Okay.
Yeah, I'll pop a little example of that, like one example out of many, right? But yeah, here's just like one little GIF I took out of a full-length video, just in the side chat there now.
Oh damn!
Right, so this is just 5 foot observer height, and this is the Great Salt Lake in Utah, and yeah, 21 miles across the lake. I'll post the full video if anyone wants to check it out as well. I'll just find it now.
There should be an equation or a ratio that exists already.
Go get it.
Why don't you go get it?
Earth is flat.
Great argument.
Oh, just debunk me.
Is there infighting going on? I think you guys are on the same page.
No, he's playing the position of, I'm going to throw any unreasonable argument to support my theory. He'll end up saying, because I say so.
Go measure it. Earth is flat.
How do you guys feel about the moon then?
Why is it
not, I feel like it's not Earth, and you want to not talk about Earth. That's what I feel like.
No, because it's relevant to whether or not
it's not relevant. It's not relevant to the shape of the. No, it's not.
Why is it not? Wait, why is it not relevant?
It's not relevant.
Okay, but it changes the way things work. If the Earth is flat, then the entire
the moon's still. Yeah, the Earth's always been flat, and the sun and moon still do what they're doing every day, and it's still flat.
You could have just explained that. You didn't have to be a dickhead about it. Just trying to have a conversation.
You don't see the sun and moon doing the same shit every day. Earth is already flat, and it's already doing that stuff.
So is the moon flat too then? Or is the sun flat? I'm confused.
No,
why are you talking about the sun and moon if they're flat or not? Who gives a shit?
Someone needs a chill pill.
The moon and the sun aren't the same as the Earth. For example, we're on the Earth and we can measure the Earth. We're not on the We can't measure the sun and the moon, so we can't make a claim to what the surface is.
I'm just asking a genuine question. I'm not trying to argue. I genuinely want to know.
I know.
That's
why I answered you.
Okay, but if the Earth is flat, why wouldn't the moon also be flat? What changes?
We're not claiming a flat planet.
I know.
We're not claiming a flat planet. Right, we're not claiming to be in the globe Earth version of outer space on a flat planet with all other round planets around us.
How does it work? It's more than just a flat thing we live on.
I'll give you the simplest answer to this that you'll ever get. It's a different cosmology. You believe that we live on a ball spinning in space, right? It's a lot easier to think of it as you're living on the floor of the universe. It's just a different cosmology.
Okay, that's an answer. Thank you. That's an actual fucking answer. That I get. I get that. I get.
Yeah, if you Google flat Earth and hit images, right, you'll see a whole bunch of propaganda nonsense, which is flat disk planets. That's not what we're claiming, right? We agree that that's retarded as well. So, yeah, we're claiming when we're talking about flat Earth versus globe Earth, we're not claiming a shape, right? The globe side's claiming a shape and a size and all that sort of thing. When we're talking about flat, we're talking about the surface area of Earth that we can test, not having any drop over distance, right? So in that context, we mean flat.
Okay, so it's just us that exist, and then the sun and the stars and everything are just kind of part of our atmosphere or some shit? Or?
Well, yeah, it's things that we can't validate for sure, right? We all see the objects, not objects, the lights in the sky, the celestial bodies.
I'm confused.
Well, we see them, right? But we can't validate exactly what medium they're in, what size they are, what distance they are, what they're made of. But we all see the same thing, right? Globe Earthers, flat Earthers, we can all view the sky, and we have it's kind of like a big clock. Everything moves in cycles.
The stars and Jupiter might be?
There's tons of speculations and educated guesses and things like that. But we in this channel, we try not to jump into speculation land, if you know what I mean, because we can't validate it.
Yeah. I'm just trying to learn about you people. I'm not.
No, you're right.
You're really fucking curious.
Yeah, so when
if you've got any other questions, Dave, feel free to ask.
I don't know. I kind of felt like pulling teeth earlier. I'm a little worried.
You're right. I think it's maybe a good idea that we explain that this server, Flat Earth, is a kind of highly emotive topic. Been around for 10 years.
I can tell.
Yeah. You get a lot of stupid people coming in and saying a lot of stupid things, and we have to, I don't know, be wary about who we're speaking to, being as we're also trying to content on YouTube and stuff. So if you've, like you said, if it was pulling teeth earlier, do apologise, mate, but you've got this far, so you can continue asking your questions.
I do have a follow-up question. I'm terrified of how it's going to go. I promise I'm asking in good faith, as good as faith as I can. But pictures of the entire Earth, why do those not exist?
Of the entire Earth?
Someone from a top down, the very top of the firmament, whatever you want to call it, getting a wide FOV shot of all of us.
Would you agree it's quite hard to go up?
Hard, yeah. It's difficult.
Yeah, cool.
Kind of possible.
Yeah, it's difficult. Yeah. So there's a certain altitude that me and you can kind of get to, and then there's technology that we're told can get you further. If we're talking about seeing the entirety of the Earth, we'd have to get very, 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 very from to do so, right? This is kind of in the realms of NASA, where they go far away from the Earth and they tell us what they see.
Cut out. Wait, you have your sentence cut out. I shit you not. I didn't hear what you said.
I do apologise, mate.
Very, very something.
Cut out for me? Yeah, it didn't cut out for me.
What was I saying, DJ?
Enough for me.
Can you remember what I was saying, DJ, if you heard it?
You said that. Yeah, I can. You were saying it's very difficult. We can only get up to a certain height.
Yeah,
thank you, mate. So it's very difficult for us to achieve a certain altitude to be able to perceive the entirety of reality. We'd have to get very far away to do so. And this is in kind of the realms of...
away. Okay.
Yeah, and we're even with the size of the Earth... Okay, so I'll try and help. So even with the Earth as we're told, right, as a ball, you have to be at least 100,000 miles away to perceive the entirety of the 50% surface of that sphere. 100,000 miles away. Just to put that into perspective, it's 238 miles to the moon. 1,000 miles, sorry.
Throw away the idea of the entirety and just say, how far do you have to go up to see enough to prove it's not curved?
Well, then, if you want to, well, that's kind of like not the question I'm asking. But if you want to really go into that, like ISS does have pictures of like however far away they are, which isn't 100,000 miles away, and they have pictures of the curve. So that's not really an argument I'm trying to get into. I'm just asking about whether or not Flat Earth has pictures of the Earth being flat.
Not the entirety of the Earth.
Entirety. That's
well, actually,
he's in the middle of explaining why you guys don't have that.
Well, because the reason why we don't have them is because space is fake, and we're not going to get pictures like that from a place we can't go to.
Yeah, and ISS supposedly don't claim to be 100,000 miles away. There's about 250.
No, that's what I'm saying. They're like they're not, because the other guy was asking just to get far enough to see the curve, and ISS is far enough to see the curve.
Well, you're asking if there's anything high up,
and then it derailed again. Yeah.
There are.
I'm asking a simple question about a picture, and if I can.
There are pictures. There are videos.
Novitate, hold on 1 second, bro. Elbow's trying to say something. Your mic's a little low, Elbow. Just letting you know.
Yeah, I can barely.
Sorry about that. The ISS is not far enough to see the curve of the Earth, according to a mathematician at that planetarium that was actually doing the math to take account for the shape of the Earth with a model.
Do you have that like equation or whatever, or like a source for it?
There's actually a video of him actually saying it. Indio has it. Give me 1 second. The mathematician, I forgot his name.
Paul Larson?
Yeah, I believe that's it.
It would be easy enough to take a picture from the ISS and do the math to where it says
apparently Apollo 11 has been far. Okay. No, not Apollo 11. Apollo 10 has been far enough away to get a picture of the Earth.
There we go. Things that have gone to the moon, so out of low Earth orbit, where the International Space Station is said to be.
You have to throw out the Apollo missions when the astronauts that were on them say that they were fake.
I'm sorry. What? I'd like to see this.
You've never seen Buzz Aldrin say that it's fake and they didn't go to the moon? You said it.
No, actually, I haven't.
Well, you can go to YouTube and you can look it up. There's plenty of videos.
Yeah,
there's a really good. There's a really good.
You made this weird claim.
There's a really good documentary called.
I'm actively searching for
there's a really cool
to benefit your argument, and I'm finding.
You asked the question. There's a really cool documentary called "Astronauts Gone Wild." Sounds like a porn film, but yeah, it's a very good documentary.
Yeah, hey, so we can give you some links to this stuff.
Yeah.
But you're asking about video or photography that here we go. This is the 200,000 on India when the India posted there. You've got other like weather balloon type stuff where they've put like a high altitude thing and they've gone, oh look, the horizon's so curved, right? Because they're using a curved lens. But you've put a proper camera up there and there's no discernible curvature of the horizon. I mean, barrel distortion is going to be doing some crazy stuff because you're looking over like absurd distances. But no discernible curvature of the horizon.
Hey, Jedi, we have good time for the gas pressure without a container.
Seriously, does it have to be me? You can do this, dude.
I'm actually doing something at the moment.
Why would you bring it up?
Well, because he was talking about space and Buzz Aldrin.
Yeah, I told him space is fake. I already said space is fake.
Together.
Yeah, I already told him space is fake, and it went over his head.
Well, just saying space is fake.
It did go over my head. I heard what you said. I was just kind of dumbfounded by that claim. But
yeah, exactly. It went over your head. You were dumbfounded by it.
It's not.
Do you want to know why?
It's a crazy opinion to hold. No offense.
Do you want to know why? We hold that opinion.
Why?
Cool.
Yeah, why?
So we're told that out there, where Jupiter, the Sun, and the Moon reside, is an ultra high vacuum. 10 to negative 17 torr outside the solar system, 10 to 11 torr in solar system. So a high vacuum. Now, to have a high vacuum adjacent to our gas pressure, the 14.79 whatever it is PSI here at grams, to have that gas pressure reside next to a vacuum, there needs to be a fixed barrier. Now, we understand that the cause of gas pressure is the force that the gas exerts upon the walls of its container. You need a container there, one, to cause pressure, and two, to stop the entropy increase and gas dispersing into the available volume, as per the second law of thermodynamics. Because that law states gas expands
infinitely
into a vacuum. So when NASA claimed that up there is a vacuum and the atmosphere that we breathe is uncontained, then that's a violation of the second law of thermodynamics, i.e. you can't have gas pressure without a fixed barrier.
I can
I'm still
offer.
looking for that Buzz Aldrin clip of him denying the moon landing, but I'm seeing so much of him saying, hell, he punched a dude because he claimed no one went to the moon. That was a huge thing, and if you don't know about that, even I know that was a thing he did. It was like 2 years ago. Some dude was like, the moon landing was fake, and then he just socked him.
No, he asked him to swear on a Bible, and Buzz Aldrin decided to punch him. He didn't.
No, that's
nothing about yelling the moon. Nothing yelling about yelling moon landing was fake.
72-year-old Buzz Aldrin punches a moon landing conspiracy theorist in the face.
Maybe it was Neil Armstrong.
Am I pulling this out of my ass, or am I reading an article?
Just reading headlines. You're reading headlines.
Well, yeah, that's how a fucking article works. You want me to read the entire thing to you? You want me to show you the video? Exactly.
Let me explain what happened.
A little bit more specific. La la la.
Hold on a second, Hazel. Hazel, 1 second, right? So that's a documentary.
You have not been provided any source of Buzz Aldrin saying the moon landing was fake. Because there is
the one with the little girl. The one with the little girl. That's the one you're referring to, right? Just bring it up.
I didn't bring it up. Someone else did, and I'm finding no video.
No, I'm not asking.
No, he's saying let's bring it up.
Yeah, bring it up. What video?
Yeah, it's a video of a little girl that
Can you provide the source and not just make this claim of like, oh, he said.
No, I'm just trying to remind people of the video that's in question so that they can grab it for you.
Is that the one where he says it didn't happen? Yeah, I remember that video.
You guys are a fucking hive mind. It's funny as shit.
Yeah, bro, look, I'll get you those videos, right? I'll go spend 5 minutes. I'll put them in the side chat for you. And I just wanted to mention quickly before I do that, right? They went around and they were asking the astronauts to swear on the Bible that they went to the moon. That was all. And if they did it, then the guy was going to donate a bunch of money to a charity of their choice. All they had to do was swear on the Bible that they went to the moon. Many of them got hyper aggressive when asked to do that. Buzz Aldrin actually punched the guy.
You think that's what happened swearing on the Bible, or him like fucking making this crazy claim that he didn't ask him to go through all the?
Don't you wonder what he had to do?
Bible.
Yeah, all he had to do, bro.
All you had to do.
Dude, all he had to do. He asked him, "Will you swear on the Bible that you went on the moon, and I'll donate $5,000 to a charity of your choice, or something like that?"
Accusing him of something.
You're just making that up, dude.
You don't fucking deal with rhetoric like that.
No, that's what happened. Watch the video.
Like if someone was like, "Hey, put your hand on the Bible and swear you didn't beat my mother."
Have you looked at the footage? It looks fake as fuck. That looks fake as fuck, the footage, dude.
There it is. There's
and your example of like he didn't beat my mother's a negative. This is a positive claim. Put your hand on the Bible and say you went to the moon.
Oh, Jesus Christ.
Yeah.
Why is he trying to change history? Why are you trying to change history? You're like, no, he definitely didn't do the thing that actually happened on video. Like, what are you talking about?
I was literally the one that told you that he punched a conspiracy.
I told you why, and you said no. And then somebody else told you, you said, oh, see, yeah, because you being aggressive towards him. Oh, man, wow.
He wouldn't punch him if there was a Bible involved. You're literally changing what actually happened, dude.
He would have punched him regardless. It had nothing to do with him swearing on the Bible. It's him.
Oh, so now you're Buzz Aldrin now. You made the decision why he punched him.
And now the Glober's got the conspiracy theory.
Buzz Aldrin, do you get to make the decision?
No, it just happened live on video for everyone to see that you haven't watched, and for some reason you're like reacting.
And you don't think there's a little bit of nuance and thought?
Yeah, and on Conan, he said, what did he say? Oh, yeah, that you watch an animation.
I was going to change that also, chat.
I've no clue what the fuck you're talking about.
You gotta add some nuance.
Hazel, can you, Hazel?
Of these clips out of context. What?
Hazel?
It's live.
Hazel, can you respond to Jedi, please? Can you respond to Jedi, please?
4 of you yelling stupid shit.
No, he had clear air and he spoke to you, and you completely ignored what he said.
I'm arguing.
You completely ignored what he said.
What did he say?
And that was the whole point of gas pressure requires a container.
Assholes.
There wasn't a fucking question in that. You're just droning on about gas pressure.
I'm the one that brought up Buzz Aldrin. I provided the fucking link in the side chat, and you're still arguing and ignoring me.
Because there's 4 of you going on. Holy shit, chill.
Here we go. So it's at 51 minutes past the hour. Anti-Pope posted that video that you were asking for.
This is the no chill panel, by the way. We'll run it how we see fit. Thanks, Hazel.
Yeah, and I just posted where he says it's an animation in the side chat there as well. So maybe go and look at the videos you keep saying we are refusing to provide.
Yes,
and then come back. We'll give you, have a few minutes. Go do that. Go watch them.
Yeah. Okay. This could be fun, guys. Like, this is going to be a lot of fun. We don't have to get mad.
Hey, Brad, if you have that USGS geological survey map, I've been looking for the link.
Which USGS map? Somebody pinged me, I think it was Jedi, asking for a Universal Transverse Mercator map.
Yeah, remember that link that we used to have that showed how the military uses it as a flat Cartesian coordinate system?
Oh, yeah, that's the Military Grid Reference System, MGRS. I can't get to it right now, but if you Google like Military Grid Reference System, MGRS, you'll see it.
Okay, I just didn't know the name of that.
I mean, it's still based off of latitude and longitude, which is a spherical projection.
Actually, no, it's not a spherical projection. Latitude and longitude are based on observations of the sun.
No, they're based off of a dual origin spherical system with one origin at the North Celestial Pole and the other at the South Celestial Pole. It's built in the Nautical Almanac.
Yeah, I've got a good picture. I drew this by hand a while ago. The enable navigation. It's in the side chat. This is the kind of map that you end up with, and this is how they hide things using maps.
Are you demonstrating an equidistant latitude longitude system?
Well, if I was to draw something with a like a sort of like a circular map, right? That's what the bottom one is. And if I was to then take that circular map and then draw it out as like a Mercator type thing, you're looking at the lines. The lines that are straight on the bottom are curved on the top, and where they're converging on one, they're diverging on the other. So it's like it shows you that they could hide land masses, like in the South Pacific. They could hide land masses using their map system, and it's sort of and these the latitude numbers, right? They are from measurements of the sun in naval navigation. That's how we got there.
I haven't seen evidence for that. I know you can get latitude with the sun.
Well, how do you think these measurements or these latitude measurements? How do you think they originated? From sailing ships, right? For navigation.
Well, I mean latitude in the north, right? But if you continue the radial lines outward, you're destroying the second. You're destroying the second coordinate point of origin, which is in the south. The spherical coordinate reference system described in the Nautical Almanac has right ascension and declination. Right ascension connects the two poles, the north and south celestial poles in the sky, and declination is orthogonal to it, kind of like latitude.
Well, declination isn't it like a compass thing, being like where the compass is off a little bit?
No, declination is your think of it as like an angular distance from the celestial equator.
Yeah, okay, but that changes different times of the year. Like that's a little bit above.
No, it's like so. This is how you know where to find navigation stars, because they are fixed with respect to declination and sidereal hour angle.
Right.
Right, and sidereal hour angle is basically the analogous to longitude.
But wouldn't the sidereal hour
declination is just a latitude?
But let's say you're not on the equator, right? You're elsewhere than the equator. Wouldn't that sidereal hour angle change at different times of the year?
It's measured with respect to the celestial equator itself. So the celestial equator can change with respect to where you are, but it itself and the stars remain in their constellations.
Yeah, no, but that changes different times of the year.
Yeah, with respect to the ground, but in the sky, they maintain their constellations. That's why they're called constellations.
We're not traveling in the sky, we're traveling on the ground.
I know. But that's why declination and sidereal hour angle are fixed for the navigation stars, and they don't move.
Yeah, we have stars that are at predicted points, right? That they are going to be at those points. Right?
Yeah, that's what I'm describing.
Sort of predict them. But sorry, what does that have to do with the shape of the Earth? Or navigation?
Well, I mean, when they develop a celestial sphere coordinate reference system, in order to use it, they have to map it to an Earth, and they have to use a terrestrial sphere. Otherwise, the mapping won't match the way they've constructed the sky to be a sphere. Well,
the celestial sphere can be a sphere, and it being projected onto a like an azimuthal type projection.
But then you destroy the second origin, which is in the south. You've taken a point and turned it into a ring in your depiction, and that's not what's observed, right? The sun doesn't encircle the north celestial pole when it's at the Tropic of Capricorn.
Well, that's difficult to prove, right?
No, it's not. It's reported in the Nautical Almanac. We're talking about the sun, right? The stars also, there are circumpolar stars in the south that don't encircle the north celestial pole. They encircle the south celestial pole. Ask any south dweller.
But since we can't go past the 60th degree parallel south, it's a bit hard to prove that.
No, you watch it, dude. Like
we can measure it.
Many people in the south.
We can measure it from distance. Sorry, Aaron.
No,
you're right. I was just pointing out that
change of stars.
This is what we measure. We can measure it from, let's say, South America.
Australia. Like we've got a flat earther who lives in Hobart, Tasmania, and he talked about this all the time.
Right. So what are you saying because I mean, I don't to actually make this argument, you'd need to first explain. I'm willing to go through it, like to explain how this navigational system works. Like let's get a whiteboard.com thing, and you could draw and explain how these coordinate systems work and how they do not apply to a flat ground.
Because I'm not access to whiteboard tools or diagrams. What I'm describing is what the Nautical Almanac describes.
Yeah, I don't understand this coordinate system that you're trying to explain. I'm not familiar with it.
It could be because you think stars in the south continue to sweep around the north celestial pole.
I mean, they may do. I mean, to be able to see,
nobody observes that.
They don't. It's not what we measure.
You couldn't navigate if you pretended like the south celestial pole is sweeping across the horizon.
Well, it's very possible it's like a reflection of some sort, because
yeah, it very well may be, and it forms a celestial sphere that people constructed.
Because if it was a reflection, it would appear to be rotating in the opposite direction. I mean, I'm not saying that.
Right. So what you're saying is it could be distorted, but in reality, it really encircles Polaris, and you have no observational evidence that it does.
Well, to understand, you're just talking about these what do you call it, the pole stars. But I'm not familiar with this navigational system you're talking about with these stars.
Do you know the Southern process? The Southern Cross makes gigantic circular arcs around the South Celestial Pole, not the North Celestial Pole.
Well, how easy is it to see that? I mean, I could probably take a time lapse.
Well, you can measure the degree angle they change, called the sidereal hour angle.
Okay.
Yeah, around the South Celestial Pole.
Well, without you drawing it and explaining, I'm not familiar with this navigational system, so I can't really...
Okay, well, go download Stellarium and plop yourself in Hobart and look south and speed up the time and watch what happens. It matches what observations are, what star trails are captured by hobbyists, and what flat earthers observe when they live in the south and look south.
It's what we see in the north, but reverse.
Have a look at this video. If you haven't seen this one, Sporadic, it might be really interesting to have a look at. I've posted a video here. I found that model to be interesting back when I watched it a few years back.
Yeah, it looks like more David Weiss azimuthal equidistant map reification of flat Earth, which is nonsense.
There's no azimuth.
Yeah, pizza Earth.
I'm not sure you even looked at what I was posting.
Right, it's what, like a crazy optical effect makes it look like the stars have 2 points of rotation, but we flat earthers really know there's just one, and it is near Polaris, right?
Excuse me. I was saying that it was something that I found interesting back when I watched it a few years ago. It was a model that was created that could explain this observation. That's all I'm saying. And if you
explain the observation without using anything we actually observed.
Sorry, say that again.
Does it provide an explanation of something we don't actually observe?
No, it's giving you an explanation of what we do observe. That's why I posted it. Yeah.
Because what we have observed in the south is documented in the Nautical Almanac over hundreds of years.
Yeah, sure. And what I'm saying is that a lot of these navigational systems were developed from observations from the deck of a ship using a sextant, and looking at the sun, looking at these different stars. And I'm failing to recognize at what point you require the Earth to be curved to make these observations. And I'm more than willing to jump on the whiteboard website and have you explain this nautical system, because it does interest me.
Yep, I'll give you the history. So the celestial sphere was developed in like the 1600s. This actually goes back to Ptolemy. It goes back way further, but for navigation, the modern versions were developed then. And what sailors were finding is for them to use it, they also had to treat Earth as a celestial sphere. Otherwise, they couldn't use nautical miles without being distorted. They could not triangulate distances using the celestial sphere on flat Earth. So they had these tables. They had tables in the 1600s of sine cosine tables to allow them to do conversions of celestial sphere to terrestrial sphere coordinates. A man named John Dalton, who invented the logarithm to give these sailors a quicker means to perform these mappings, because the sine and cosine table method was crazy. And the system carried on forward through the Haversine formula.
I can give you a good,
in the 1830s.
Thinking on the fly, I can give you a good explanation for that. So if you imagine just like a table, right, and pick 2 different points on the table, and then imagine like a dome around that, because in the single point from that flat surface, from that single point, looking.
That's not what we observed.
Hear me out. These are azimuthal projections, right? It's like a spherical celestial sphere, right? So you move to a different spot, right, and then that dome is obviously there's going to be some. You're moving to a different spot. Obviously, the observation is going to vary. It's going to change over that distance. So there's going to have to be some sort of correction.
Yeah, and what they found is they could not triangulate distances. So there's several problems, right? You could get position fixes just fine by spreading out a map as you've depicted, the pizza map. You can get position fixes flat or globe, just the same. You can also calculate meridional or longitudinal distances just the same. But if you start deviating from there, you're going to form curves like what I showed you, and you're not going to be able to complete triangulations and get reliable distance measurements because you're using a sphere to a flat projection.
I'm going to say excuse me through the middle of his sentence, dude. Let him finish.
Because he changed the
Let him finish then.
No, I took your dome. I explained your dome and the problems with it.
No, you're talking about calculating heading changes, or what heading you should be on to get to a particular location. Let's keep it as in its utility. What we're referring to is naval navigation, right? So talking about heading changes, right? When you're talking about different points on a flat surface using a celestial sphere, there are going to have to be corrections because you don't know where you are in relation to that celestial sphere. That has nothing to do. That calculation change wouldn't have anything to do with the surface being curved. I'm not sure why you're referencing it, why you're invoking that.
Well, because what sailors realized is they couldn't triangulate distances. They could not form triangles.
Yeah, it's difficult math.
Well, right, but they had the math figured out. So listen, you're going to have a curving baseline.
They don't have accurate maths.
Listen, you're going to have a curving baseline if you use this. Whether that, and this is only a curving baseline when you deviate from a meridian. And if you don't use a globe to curve it in the vertical axis, call it the Z, you're going to have to curve it along the X and Y axes, left and right. You're not going to be able to use straight line distances with the mapping and be able to complete triangulations. You're going to have to curve your your sides of your triangle, or leave this one side of the triangle open.
Sure, I'll take your word for it. But like I said previously, without actually going onto a whiteboard application and showing me this, I'm not familiar enough with this navigation system to actually fully comprehend and understand, be familiar with what you're talking about. You'd have to show me in a visual way.
So this navigation has been around since like 4,000 years ago, bro.
Right, and I'm not a globe earther. I just understand that the spherical coordinate reference system itself was a choice, a philosophical interpretation going back to antiquity. There are, and you brought this up, other ways to reimagine the star field, not as a sphere. The problem is if you start invoking latitude and longitude, you're putting it back into the sphere again. There are star systems that are XYZ Cartesian-based in 3 dimensions that the military uses for station keeping for satellites and drone operations and so forth. These use an XYZ flat system.
Yeah, I didn't say that.
They have nothing to do with a sphere in the sky.
No, that's not what I said. I never said that.
I know you didn't say that. I'm actually telling you that what you were proposing still used latitude and longitude, which means you're still using a form of a globe projection or celestial sphere projection. And we can step out of that altogether by using a 3D vector-based star field and XYZ Cartesian space, as is done, like I mentioned.
Like I said, I'm not familiar.
Yeah, I know. That's the implication whenever you say longitude and latitude. So you're working within that system, and you're trying to say you can't get a flat coordinate system from that. It's just not going to work.
Precisely.
Absolutely.
No, you can't, dude. He's not going to get it. It's fine.
It's a mapping issue. You're going to have a distortion from one surface to the other. The surface of a sphere is irrational. You cannot take a basketball and wrap it with wrapping paper successfully without making all kinds of weird cuts and stuff.
Have you seen that Schur Magellan map that was right? Latitude is gotten from taking a measurement of the sun with a sextant from the deck of your ship. And the longitude is your compass direction in relation to something, right? A celestial point, for example.
He understands where you're coming from, dude. He knows where you're coming from. It's not that it's lost on him that he doesn't understand what you mean. But you're not really getting...
He's saying that to invoke latitude and longitude, it has to be spherical. I don't understand that.
Yeah, he doesn't say. I knew he wasn't going to get it. It's difficult.
I get it.
He's never heard the argument for it because it's a system that was designed. The way it's designed is to plot things in the sky as if the sky was a sphere. But the only way to do that is to map the ground as if it's 1, 2.
No, it's not.
It's a model, dude. It's a model-based system. It's not actual. I think that's what you're not realizing.
The reason that you would map the sky as a sphere is because assuming that everything is at an equal distance away, you can arc through the sky. Everything you're looking at, it creates a dome above you. So,
yeah, that's a human conception.
Yeah,
and that's also the trap.
Sphere doesn't mean that the ground is kept. It means that the map.
I know. The celestial sphere is the trap. Pythagoras looked at the sky and said, "Man, it kind of looks like it could be a sphere, and a sphere is the most beautiful fundamental shape. It's basically got one face, and it's perfectly equidistant all around from a point of origin. It's beautiful." And so ever since then, even prior to that, they've been plotting the stars using the system. And yes, you can use it that way. It's not the only way to interpret the stars.
I can give you an example. Sheppa, I can give you an example, right? Let me give you an example. You know how you see the clouds above your head? So the clouds, you can see them at an angle of degrees, like in front of you. Looks like they're heading towards the horizon, like it's ramping down.
Yeah.
But we call that perspective, right? Okay, think about this. Raise an altitude all the way up to the cloud line. What are you going to see?
Oh, the ground rising up to the clouds.
No, once you reach the cloud line, what are you going to notice? The clouds are sitting on a horizontal plane.
Right.
When you're on the ground, you can't notice that because of the way you see with your eyes. You see in perspective, right? So everything looks like it's converging to the eye line, off in the distance. But when you raise an altitude, you find that you actually reach the cloud layer. It's on like on a horizontal plane. You get it now?
This is the magic trick, dude.
I don't think he gets it, but I'm trying for him to.
It's a really good explanation, dude. So from down here, the clouds look like they're ramping from the horizon, creating an arc. But when we actually go and investigate the clouds, i.e. level, they're actually horizontal.
Yeah.
The sky actually isn't curving, obviously, but we can use this concept to create a map.
Yep, and a model. Yep.
Mm-hmm.
That's all we're saying. That's the hat trick, bro. That's the reason why people think the Earth's a globe. It's been reverse engineered to think that way.
I think a curved coordinate system is a way to hide things.
What do you mean hide things? I don't...
Like to say that
you're not wrong, okay? I agree with you on that point, just from a slightly different vantage point of perspective. Because I took the celestial sphere from the Nautical Almanac, and I mathematically stripped out the rotational vector. And then I tried calculating distances from like Tokyo to Santiago and got vastly different numbers. I could use the system to complete triangulations and everything on a flat Cartesian world, but I started noticing that there is a lot of fudge factor between the tropics.
I think you have to be talking about this a little more sporadic because There's some people that still in the flat Earth community they're still lost on this point.
I chose those two locations because they're running diagonal, not close to meridional lines, and it was also a trans-celestial equatorial distance, which means it crosses from the north to the south. And so this is like, and also over the ocean. This is like probably the biggest, hardest problem.
To have this conversation in a meaningful way, you'd have to visually explain it to me because I am not familiar with these.
Yeah, well, I demonstrated the visual. It's the hat trick. You're seeing in perspective, which means that everything's converging to the eye line. So to you, everything seems like it's a dome above your head. But once you reach to a certain layer, you can actually notice that things are actually horizontal. But you're not in the horizontal. Just imagine looking down. I'm going to simplify it. Looking down a long corridor. It looks like the ceiling's ramping down. But when you get to hold on. Yeah, but the way you see, the way your eyes are looking, and your explanation as to why we can use longitude and latitude, like you're trying to still work within the framework of their conception of it being the globe. They're working within a globe model. So when you keep invoking this, you think that you're going to be able to extrapolate a horizontal coordinate system. That's the problem. You're trying to insert something that doesn't belong.
Yeah, so like in your example with deriving latitude from the sun, in order to do that, you need to basically wait for the sun to be at a tie point, and you also have to know, and then you measure that angle, but you have to know what time of year it is. And the reason why that's important is because of the sun's declination with respect to the celestial equator. Once you have those, you can derive your relative latitude. And that latitude is with respect to the polar origins. And there are two of them, not one.
It's going to take a minute for this. Yeah. Oh, thanks, DJ, for that. Yeah, I think DJ has put a video up to kind of exemplify what we're talking about with the cloud layer. And that's really interesting once you start to notice this. And you're like, you know what? The clouds didn't look like that on the ground. It looks like it was kind of like arcing over my head and going to the horizon. I'm telling you, man, it's amazing when you actually start to see the world for what it really is versus what people are conceptualizing it being.
Yeah, they hijacked how our eyes perceive the stars.
Yes.
You know, and we can take that same perception and back engineer the radius of Earth.
They've hijacked perspective all over the place in this instance, right? One with this celestial sphere above our heads, which isn't actually there, but looks like it is. And then we're making predictions about how far hijacking perspective, actually not put it into the equation when that's be able to see things before they disappear. So it's perspective all over the place. They've just turned into a ball.
Right. The Earth curvature calculator is really an angular resolution loss calculator.
Mm-hmm. Yep. I just gave it an Earth curvature calculator name. That's right. It's because of Earth curve, right? This is only happening because of Earth curve.
Yeah, it's like stop focusing on the bottom for the sake of the argument of an object that's getting smaller on the horizon, but look at the top and how it scales. It's scaling with perspective. If there's curvature, it would scale with perspective and it would drop at a curving rate. But both of those are not present in any observation anywhere at any time. Only one of them is perspective.
That's why when we're describing flat Earth, it breaks them because they don't understand how they're trying to square the circle of how they're using a system that's showing them that it's operating on a spherical model. Yet we're showing them that the Earth observationally looks flat on the surface. So they don't know how to square that, and we're trying to insert the idea of using their system to debunk their system. And we're not going about it the right way if we're going to use that. We have to show them how the Earth is demonstrating, like either physics of water or how we can reach certain layers, like the cloud layer, and it doesn't look like the arcing over our head anymore from the surface because we're reaching the layer where the clouds are. That it's actually a horizontal plane. So you're starting to notice the inconsistencies of the globe, but it should be consistent in being curving, and it's not. It just doesn't present itself that way. But it's difficult because the vantage point that you have is from the ground, so you can only see what you see from the ground, and then you're trying to make the assumption that it's arcing over your head. But if you actually reach that layer that the sun is, perhaps it's not. It's just moving straight across horizontally. I'm telling you, they hijacked perspective and they turned it into this model.
Mm-hmm. You know what's neat about the celestial sphere model, guys? Distance calculations along the longitude lines are the same flat or globe. Facing either origin.
That's why they can't produce the evidence that the Earth is physically a globe, because it's just not. So when it's time to belly up and say, okay, let's do this thing. We got all the models now. Let's try to match the model to the Earth. You can't do it. It's never going to happen. You can't do it one for one. It can't transfer over that the same system is going to show the curving surface like the way they did in the model. So that's why it doesn't work.
Yeah, the practical way to demonstrate that is how I said earlier. Take a basketball and try and gift wrap it for a friend. You're going to have a hard time.
Got any of that curving paper?
Yeah. It's important that we represent the globe's claims accurately, too, so as not to strawman the argument from the get-go, because then nobody will take us seriously when we start debating and discussing these topics. Yes, this means there's potentially a lot of work to do as far as research and breaking your brain open
to understand things like higher geometry, like projected geometry and differential geometry. But you can also argue flat Earth in other ways that doesn't go there. Just stay out of that topic if it's really difficult and spend some time learning it on the side. Long distance observations are great because what we still need at the end of the day to prove that Earth is curving is that curvature measurement. Take the elevation angle to Polaris. It'll work, and the distances are the same flat Earth globe geometrically. But the tiebreaker is what exists in reality, and that's the curvature measurement, which they don't have, and we have observations and measurements of a flat Earth instead.
I want to know if the reaction from the chat is if anybody's ever heard of what we're talking about right now, or is this something new for everyone? Is anybody learning from what Sporadic has been saying thus far? What me and Jedi and Evan have been talking about? Or have you known this already? Like, what's the reaction from you guys?
I know it kind of throws a little kink in the elevation angle to Polaris argument, but this is really the accurate way to represent it. Sorry for Nathan Oakley's book.
No, that's what I'm sitting here thinking. I think exactly that as well. Sorry for Nathan's book.
Yeah, some of us already knew this intuitively without knowing how to express it geometrically. And we knew that we also needed a curvature measurement to back up the elevation angle claim. And that's why it's you know, when you're pointing directly at the origin along the meridian, you don't have to curve anything because you're operating on a great circle route. But a great circle route that deviates west or east from that north-facing or south-facing meridian will experience some kind of deviation itself in either the z-axis or along the xy. So when you flatten that out, you're going to have to show a curving baseline one way or the other, depending on your latitude and direction you're heading. Or you're going to have to curve it around a three-dimensional sphere. You're actually a two-dimensional sphere in a three-dimensional embedding space to get technical.
Say that again. A two-dimensional sphere in a three-dimensional.
Yeah.
Okay.
The surface of a sphere is two-dimensional. You can express the location in xy.
Gotcha. Thank you.
Yeah.
Yeah, now I get it. Yeah, that makes sense. Now I can see it in my head.
Kind of wish Indio was here because I think he can offer additional points on this. He spent a lot more time talking about this kind of thing than I have.
And we also got to address the fact that observations are what people are making of when they think of the sky and the way it appears. So we can't negate the fact that things do look like in perspective to be arcing over our heads, but that's the reason why I'm saying that it's always important to talk about our observations, making sure that we're thorough with our explanations.
I mean, part of how we see the world is psychological. You find topics of vision and perspective being discussed in fields of psychology.
And one of the most important things, I think we were talking about this topic and the topic of like how people see through the medium of air off into the distance. Me and Indio had discussions about this previously, but it's hard to determine at any given point, like with a still photo, like, because I've always seen that being like put around, like still photos and shots from distance, you know, like target distances. Like people are declaring that this is the case for like an observation being made with an image. And so there's a lot of distortion that can happen between here and the target distance. So how is it possible that we're making these declarations of like where something is based on these target distance observations through an image? Like I think that's important as well. There's been a lot of declarations being made on both sides. So.
Keep proving day after day that our community is really at the forefront of this in terms of the sharpest arguments and the best foot forward, I think. It has been a group effort.
That's an awful lot of flack for bringing up two celestial poles, I know.
It's been such a hard thing for flat earthers to deal with because those of us who've been in the community a long time got really comfortable with the AE map.
Mm-hmm.
And the AE map, the issue isn't the terrain, it's the coordinate references. It's the geometry itself. Delete all the terrain markers, delete the continents, delete the oceans, delete the labels, and just look at the grid lines itself. That's the problem. What people often neglect to understand is azimuthal equidistant maps have what's called a non-uniform scale to account for the mapping distortions because they need to represent the coordinate reference grid as a sphere, but they can't do it on a 2D surface very faithfully. The second point of origin, being the South Celestial Pole, is not a point, but a gigantic ring. It's been blown out.
Mm-hmm.
You can't use it anymore as a point of origin.
No. And then we get into the problem of saying 180 degrees from north is south.
Right.
Because then we're going to have a problem with our lines of longitude. Because if we've got them all splayed out to a pole that's been stretched around a circumference, then it's going to be hard when we've got two, got two actual geographic or celestial poles. Say actual celestial pole anyway.
We can throw the bullshit flag down on the 69 and 1 rule, or the 60 nautical mile to 1 degree elevation change rule. It is based off the celestial sphere. Mathematically, geometrically, it is consistently applied. But is that the true distance traveled? Does it hold true and accurate for vast distances?
It's really hard to tell across the sea and the oceans, right?
Yeah, because what the Glober will come back with is GPS. They'll talk about the time of flight, sending an arrival of signals and stuff, and how it just maps out perfectly to a globe. But that's because the GPS is built using the spherical coordinate reference system in the first place.
Yeah.
So they aren't doing an external critique of whether or not that coordinate system itself is accurate. What you'd need is to apply GPS to something like, I don't know, a 3D vector-based Cartesian XYZ grid of the stars. Or apply it to a completely terrestrial-based coordinate reference grid that ignores using the stars always and forever. And then use the flat planar distances to see how you can measure that. And if you can get what you believe to be pinpoint reasonable accuracy using a planar system, and it doesn't square with the spherical coordinate reference system, then one of these is probably not true. And the tiebreaker is, folks, the curvature measurement. So you need to externally critique the spherical system by using a non-spherical coordinate system to externally critique it. Try planar, try Cartesian stuff, Euclidean stuff, not spherical triangle stuff. If you use the latter, you're going to be affirming that you're going to be basically circular logic. You're going to be going around in circles, affirming the consequent over and over and over again. It's why these funny little games that like MC Toon and others play, where they're like, hey, can you triangulate these distances on a flat Earth? And then he gives you a spherical coordinate reference system to use. It's a freaking trick.
It is, yeah.
And how many flat earthers fell for it?
Loads.
Many.
Yeah.
It's a trick for the precise reason I said. Unfortunately, we don't have a fully developed planar survey system of the entire world. We just don't. Nobody's bothered to do it. Well, hold on, I take that back. It probably does exist based off of the use of these 3D vector-based starfield Cartesian reference systems that are used in military applications, and they're black boxes and nobody has access to.
I had a guy in here earlier that was actually talking about that, Sporadic. And I was like, there's a guy in here that, yeah. He's like, imagine if and I forgot the name of the corporation, but it's a satellite company that deals with mapping the surface of the Earth. So he's like, if we could look at the technicals, the inside of that box, they could probably find out what type of system it's using in order to map. And then we don't have to go to like a government and ask them if they're using, any systems to show that the Earth is a globe from the system itself, but we could actually see if they're using it through what type of information that computer system has been given, So he was kind of going at it from that side, and I was like, that's interesting. That's an interesting point.
The thing is, they'll use that kind of system and then map it to a globe, and then present that to you.
That's what I'm saying. Like, how do we know that system is not using that, or if it is? Like, wouldn't we be able to find out by the whoever developed that system?
Yeah, I mean, I've got some academic papers on this and some blog stuff. But hold on one second. Actually, I posted this in a back chat.
Because I think that's where the money is, right there, where you start to realize that all these systems that you've been using are all just spherical based. That would at least start turn a few heads,
Yep. So this stuff is out in the open. Like, it's not just exclusively for military use only. I mean, it's using scientific research stuff, but it's still very much proprietary. Nobody's bothered to develop this for the public for land use. The people who've designed this themselves think they're designing freaking like star charts for Wing Commander video games in outer space. So this stuff is out there. Like, there are examples of things I described that completely sidestep the globe altogether, independent of Earth's shape. And you know what? It's going to produce different distances than what we've been used to. That's
were these systems able to be tested and proven? Because I think that's the other thing too. One would then realize, like, okay, we got this other system that's not been tested, whereas we have this spherical coordinate system that has been. So I mean, just even talking about it, like, how would we be able to put it forward that these things can be tested and then also verified?
Yeah, we can't. I mean, we can't use this as a positive claim at all. What we can just show is, here are examples of ways to track location and perform distance calculations that don't use the globe and are actually used professionally. And then just leave it at that. Like, I have no way to assess the validity of this, neither do you. I mean, the people who design these are just putting them forward in white papers and building rinky-dink devices for themselves and playing around with them. And then there's like high-end applications where they're supposedly using high-altitude platforms and stuff. Nobody's got access to any of that.
So that's on both sides, though. Both sides would have the inability to actually look into these systems and see if verifying them to see if they can actually work. But the only thing that you can do is work out mathematics. So the calculations would be as such to be performed for distance measurements, like verified, from point A to point B. So either the math would check out that you don't need a globe, or the math would check out that you do. But either way, you're showing that there's a way to look at this without having that spherical coordinate system invoked.
There could conceivably be a spherical coordinate system that does check out and works like we would envision. And this would invite a lot deeper philosophical discussions as to how this realm actually works.
What do you think about the layout of the continents close to the north on the AE style map, the Gleason map? Roughly accurate?
I kind of think so, just from use.
Just from actual world, like consistent. It takes X amount of time to get here, and if you go in that direction, and then you kind of plot them out, and it seems to, I would imagine, check out mostly to that layout in the north.
Yeah, I'd have no problem accepting that. There are a lot of things that without verification that I would accept. It doesn't bother me. And I leave it such that I would love to be pleasantly surprised if I'm wrong.
Yeah, I don't know if that's one way or the other with the conversation that we have here. That's not really a deal breaker in any way. However, it's interesting that everybody would have a different orientation positioning for these things, and depending on what map projection you use. Because think about it, if they're trying to design, like there was a time where, what's his name, Antonio Subrat's, Mark Sargent trying to figure out like the continent orientation and the landmass size and such. Well, if that was the case, why were they trying to do that if there's already something like you said is already good enough? The Gleasons or the AE. Why would they be trying to figure it out?
The weird thing is, guys, like if you go to if you go to where you think the equator might be on the equinox, not saying that that's consistent, and you observe the sun rise at 90 degrees east and set 90 degrees west, it doesn't appear to deviate to the north or to the south whatsoever. It's not like it's going in a gigantic racetrack around Polaris, is what I'm saying.
Yep.
You mean if you're like standing somewhere near the equator? Is that what you said?
Yeah, like on Ecuador.
Yeah, on the equinox.
Yeah. Mm-hmm.
There's if I'm not mistaken, there's a diagram that shows how the sun throughout the year from Cancer to Capricorn looks like it's going a straight path, like across the sky. It doesn't look like it's going around Polaris or, Sigma Octantis. So it does show, however, it does deviate north and then south, but it's not doing in a like circular way. It's just moving straight across the sky.
Here's what's bonkers. That you experience at Ecuador on the equinox may not be experienced the same way also on the equator elsewhere on Earth.
Oh, that's
you might have to wait a few weeks.
Oh, I knew there was a time variation of when we could. Yeah, time's something to do with it. I've been asking about the good couple of now.
Here's the other thing. Here's the other thing too. I don't know if you've looked into this or not. People are saying that there's this circular motion that the stars are doing with the star trails. Do you think they're circular? Because wouldn't that mean that a star would start at a certain point, end up back where it started?
Yeah, no, that's not what happens because of the drift over time, like from day.
So they're not going in
where it started from.
Oh shit!
Yeah, it's not a perfect circle by any means, especially over the year.
Yeah, the whole thing is like a drill. If you could picture a drill bit where you've got like the north celestial pole on one end of the drill bit and the south on the other drill bit, the stars do spiral going one way and then the other way.
Mm-hmm.
So if you go out at the same time every night and look at a star, every successive night you go, if you're like in the north and it's turning it's going to towards summer, right? No, towards winter. Crap, I have to think about that. But the star will migrate it'll migrate to the north when it first appears in the sky. It'll also appear a little bit higher in the sky. And then it'll start to go back towards the south and back lower in the sky again. And all the stars do this, even circumpolar stars. So it's a gigantic helical motion.
Yeah, they have a barycenter as well, don't they?
Well, yeah, that's a whole other thing. Not all the stars have that. They have like what's called proper motion. There are going to be some deviations in their paths. Yep.
We don't even get to these types of conversations, man. I'm telling you.
We need to have more of them.
Well, also, if anybody has any questions, I think it would be a great time for anybody to chime in with.
Yeah, I got a question. How many people who claim that the TFE debunked the azimuthal equidistant map, how many of them can actually draw their claim of Polaris at the center of the star field and the Celestials, and all of them rotating around Polaris. If you try drawing that, you're going to take a piece of paper, you're going to put a dot in the center, that's Polaris, right? Then you're going to draw a bunch of dots around it, right? And then you're going to create a rotational, you might draw a little arrow showing the way they rotate, right? And then you could draw radial lines out from the center to get longitude, or whichever one is by time. One of them is, in the north, the elevation equals to Polaris, and then the other one is the time. I can't remember off the top of my head which is which at the moment. But anyway, you end up with circles, right, that get larger as they go away from the center, and then you end up with radials that start at the center and then splay out. You could divide them by 15 degrees, right? Then you look at what you just drew. What does that look like?
A bike wheel.
Right, but it looks like the azimuthal projection, right?
Yeah, sorry, yes.
So on one side, you're saying that this disproves the azimuthal projection map because you're synergizing the celestials with the terrain. But if you try to draw your claim about how the stars are relating to Polaris, you end up with the exact same thing above the surface of the Earth, and then it's just, you can just pick your poison of where you want to place the continent. You see what I mean?
Mm-hmm. Totally. Nailed it.
Yep.
That's why people that don't know how to draw what they're talking about, just try drawing what you're talking about. Sometimes it elucidates your errors in your thinking.
We could also ask these folks to draw what they think they're seeing when they're observing the southern sky from the south at night.
That'll be some interesting looking pictures.
Dude, it'd be as bad as the Globers with the Selenelian eclipse diagrams.
Well, we had a whole bunch of fights over the past months in regards to TFE because there are plenty of people who were getting mad about people who live in the south telling them what they saw, and they know that's not true because everything circles around Polaris. And so you can't have a differential of an apparent rotation point that to you, from where you're standing, looks to you, and you can describe it in language that would be considered a rotation, right? Because it revolves around Polaris. Whether they realized it or not, they were actually shoehorning the azimuthal equidistant assumption of the flat Earth model, quote unquote, strawman that Globers come up with, where they say, you have a pizza disk map, and then you have the celestials right above it rotating in a consistent manner. But that doesn't jive with what we see from these different locations on the Earth. And rather than just conceding maybe that's not what people see from these different locations, these flat earthers, by the way, would say, no, everything revolves around Polaris, and it must look that way as if I'm describing it from a top-down view. And not even considering that somebody who lives in Australia just told them, that's not what I see, bro, with my own two eyes. Rather than say, hey, I'd like to see the evidence, some of them just immediately called those dudes liars. Because they were so ingrained with this idea that you have splayed out radials and these giant circles, and everything is on one of those, and it's rotating around Polaris, and that somehow that means it should look that way from the ground. Which doesn't follow, by the way. If something is mechanically moving in a particular manner, it doesn't mean that optically you're going to be able to interpret it correctly. We all understand this, right? We've all seen this in our lives, right? For example, you've seen wheels on cars, they spin backwards. The car's moving forwards, but when you look at the wheel, it's spinning backwards. Why? Well, because it's an optical illusion.
That's funny. We've had some flat earthers come in and say something along those lines. They say, yeah, all the stars do, in fact, move around Polaris in reality, but there's a crazy optical effect that makes them not appear that way in the south.
Yeah. We can't have it both ways. We can't have the Australian friends that we know be bold-faced liars about their own experience, and then people who've never left the north, trying to tell them that this assumption about everything rotates around Polaris works out as if it's like a kid's artwork. But those things don't jive. But I would be satisfied when any one of them goes to the star field, turns around, recognizes the Earth's location relative to where the stars actually are, and gives me those coordinates directly. When they do that, maybe they have a point. Until then, their dogmatism about what's going on in celestials is no different than Glober dogmatism. It's tit for tat. Globers have no idea where the celestials physically are in relationship to the Earth. Flat Earthers have no idea where they physically are in relationship to the Earth. Globers who claim they do are talking out their butt, and Flat Earthers who claim they do, guess what they're talking out of? Their butt.
Would you then say, Mr. Overlord, that the way to arbitrate this problem is to actually provide a curvature measurement of the Earth?
Well, that depends on what you're arguing about. If you're arguing about whether the Earth is a globe or not, yes. But if you're arguing about, what is the best way to utilize the celestials in a manner in which they can be used to navigate or tell time or whatever, it's like you can create whatever kind of model you want that has however many steps removed or however many assumptions or reifications. And if you arrive at where you ended up, does that mean that all of those things you did prove that your interpretation is reality? No. It's well known that models don't necessarily equal reality. It's well known that maps don't necessarily equal reality. In fact, the shining star example in the majority of lexicons and dictionaries for a reification fallacy is literally a map. It's the example that people think the map is the territory. That's literally the example of the fallacy. For a reason. Because most people make that mistake. In fact, friends, we had a flat earther in here the other day that we had to argue with, who was arguing that if you have a building plan, right, that shows a side view of a house, arranged horizontally out on your building table, and you're getting ready to understand what you're about to do, he was claiming that the lines on the piece of paper are actually vertical. So if I drew a square, I'd be drawing 2 horizontal and 2 vertical lines, and he couldn't fathom that the axes called vertical on a piece of paper can be oriented in any direction. It doesn't have to be oriented vertical. Therefore, it's just a information state rather than an actual orientation, because you can orient that piece of paper any way you want. But when you erect the wall in physical free space off of your floor, then your wall will be vertical. But before that, it's just a drawing on a piece of paper. There is no wall. You get it? No wall exists until you build it, right? We all understand that?
You mean you don't have to begin building the roof from a top-down plan map?
Holy moly, dude! Don't give me PTSD, bro.
Yeah, go ahead and try doing that. I think that would work out. It looks like we got the party going. So we got Master Aritosis. If you're there, welcome to the room. You got the capybara it looks like a ninja capybara or a samurai or whatever. We got John Luna 8383. Welcome to the room.
Yeah, so while they're thinking about whether they want to answer or not, if anybody's prepping you on this point, don't even argue. Just tell them, hey, can you draw that for me? Then just wait till they do before you continue the argument. There's no reason to fight with them over concepts that are better illustrated graphically, because they're trying. Most of the time, the argument only exists in the fact that they haven't put it to paper and put their ideas into fruition. Right? They want to argue with you with words. They want to tell you you're an idiot. Everything rotates around Polaris. Okay, well, how would you draw that out? You're an idiot. Everything rotates around Polaris. Hey, I may be learning impaired. I need a graphic. Can you help me? Give me a graphic of how that would look. Hey, you're dumb. Everything rotates around Polaris. East to west. East to west. Everything rotates east to west. Like, all right, dude, you're a broken record. I guess you're not going to help me understand what you're trying to say. You're just going to make fun of me because I'm not parroting the mantra that you're parroting. And you can't explain it to me, so I'm just going to assume you're just as dumb as you were when you were a Glober and just giving you out.
Yeah, I've been telling the Globers for years to draw me their diagrams of how they're claiming refraction works, and not one of them has come back to me with a diagram. I'm still waiting. I think it's a good idea.
Well, what about so Walter Bisman tried, remember?
Yeah, he didn't bring it to me, though. Yeah, I did see that.
Yeah, that's true. That's true. He didn't respond to you, but he did respond to the community by trying to make one in regard to attempting to prove that refraction explains the black swan, whatever the heck that means. And so what he did is he drew a bunch of, he laid it out orthographically, and then he drew a bunch of lines from where the oil rigs were and the horizon beyond the oil rigs, and then he just traced those lines back with a pencil, essentially, back to where the observer was. But here's the problem. In order to get it to work out, he had to crisscross the lines before they met the observer's eye. So if you know anything about vision, people listening, everything gets flipped on the focal axis. And then your brain flips it up right side up. So your retina is actually receiving the image upside down. So if it already flipped before it reaches your retina, that means it's going to be double upside down. When your brain's going to flip it, it's going to be upside down again. So in order for Bislin's idea to have worked, the oil rigs would have been upside down. And this is supposed to be the intelligentsia of the globe Earth, defenders trying to answer the problem of the black swan. I mean, give me a break, dude.
Great point. I like it.
Well, so we have to do some nonsense like that. Let me think. Who's that beard boy? It's all uppity all the time about flat earthers are moral degenerate liars who probably hate God. Who is that guy?
Beard boy? I don't know, but yeah. I like that.
Answers in Genesis.
Oh, this guy. I was just talking to somebody about that guy yesterday. Oh my gosh, don't even get me started on that guy. I can't stand that guy.
He tried showing some of his homemade observations to Indio, supposedly showing the bottoms of boats getting cut off and talking about it, and then Indio put it into his software. He's like, dude, why'd you crop these pictures? Why are you changing the perspective of the pictures? Why aren't you just giving me the actual raw pictures to look at? Busted it right on the spot.
Oh, I'm sorry, I missed that. When did that happen?
A while ago. We got it somewhere.
Okay, because that could have been the time frame where I was I couldn't even trust myself to be in the same VC with that dude, because those guys who they'll say, oh yeah, there weren't any dinosaurs, but yeah, on this little globe thing, we gotta, trust the scientists. It's just come on, guys. You're just leading people astray consciously. There's no other way to, there's no other explanation for what you're doing there. You're leading innocent souls astray, no doubt. So I just can't even be around that dude anymore. But I'm glad Indio got him. That's good news. I might have known that at the time and forgotten. I don't know, but thank you for reminding me.
We did a whole episode exposing his vilifying hatred towards flat earthers in his blog post.
He's such a weirdo, yeah, because those guys, they don't only just, try to keep reifying the fantasy globe religion. They they claim that flat Earth is a psyop, that we are the ones who are satanically leading people astray. It's like, oh my gosh, guys, like you are just so out there. It's outrageous. But I guess if people are going to be led astray by that, I don't know. Like they got to have some disconnect themselves, don't you think? I mean, if they're going to say it's similar to what you've been saying, people are just going to want to follow a leader. If they're just following leaders and answers in Genesis and saying, oh yeah, no dinosaurs, young Earth. But they told me that even though the Bible says the Earth is flat, it's really not. So I guess I got to follow them on that too. Then that's their problem, right? So maybe I could do that and not be as angry as the dude because, he's just a snake oil salesman, and the people are buying the snake oil.
He's relevant to that because there's a large community of churches who are met with people in their congregations that become flat earthers and they have to deal with it, right? So I overheard a conversation with somebody talking about it, and he wasn't really answering the flat earther that well. And it got to the point where he had to give like a more accurate answer of how he's going to respond to it. And he basically offloaded his responsibility as a pastor to lead his flock to answers in Genesis. He basically said, listen, I just refer to answers in Genesis. They're more professional. They're like experts on these things. They've got, this astronomer dude, yada, yada, blah, blah, blah. So I'm just going to, trust that they're capable to give me the answers on these matters. Right? So he's just saying, I'm going to go to answers in Genesis. Whatever Danny Faulkner tells me is what I'm going to tell my congregation. I'm not going to do any more further research than that.